Hey everyone, 11.9 video coming at you. We're going to solve example 6 very quickly. Find the power series for f of x equals arctangent of x, along with the interval and radius of convergence. It's going to be very similar to the ones that we did in class. So first, as we did in class, note that while arctan of x doesn't look anything like 1 over 1 minus x, its derivative does. Right? F prime of x equals 1 over 1 plus x squared, which is 1 over 1 minus the quantity negative x squared. And when negative x squared is between negative 1 and 1, we can write that as a geometric power series, right? Perfect. So if negative 1 is less than negative x squared, which is less than 1, which is equivalent to saying if x is less than 1 and greater than negative 1, then f prime of x equals a geometric series, right, where a equals 1 and r equals negative x squared. So we have the sum from 0 to infinity of a, which is 1, times r to the n. Right? And just so that we're clear, that also means this is 1 minus x squared plus x to the fourth, if you will, minus etc., right? If you wanted to write that down, right? Okay, anyway. So f of x, we know, is the integral of f prime of x dx, right? Which, of course, is the integral of the sum from 0 to infinity of negative x squared to the n dx. By the way, should point out right here that the radius of convergence is 1 as well. Right? Just to answer the question, right? Okay, so anyway, remember, when you're integrating this, be a little bit careful. Right? Don't just integrate negative x squared to the end. Like that's, you have to separate the coefficients from the variables, right? So we're going to rewrite this as the sum from 0 to infinity of negative 1 to the n times x squared to the n, which is x to the 2n. And it's very important that you write it that way. Because again, now we can integrate the general term. And if you don't believe me that you need to do that step, try integrating negative x squared to the n using the reverse power rule. It's not going to work out, right, if you compare integrating it with, say, that term. Okay? So we're going to wind up getting negative 1 to the n times 1 over 2n plus 1 x to the 2n plus 1. Oh, and by the way, sorry, we're not actually integrating that. So just the sum. No integral. Sorry about that. And then, of course, we have to do plus c. Okay? So that would be our answer, but we do note that we have an initial condition. So I'll say also note that arctangent of 0 equals 0, right? Because tangent of 0 is 0. Right? Well, that means that f of 0 equals 0 on the one hand. On the other hand, it equals the sum of 0 plus c, which is 0. Right? So c equals 0. So once again, we have a value c that's just it's 0. Right? So really, the power series for f can be written like this, right? Sum from 0 to infinity of negative 1 to the n, and I'm just going to divide it by 2n plus 1, x to the 2n plus 1. And just to be crystal clear, we have that all x are in negative 1 to 1 with radius of convergence 1. Right, if you want, you can write I equals negative 1 to 1 if you prefer.